Hello everyone, this week we have come to a new chapter, the chapter 3, focusing on stoichiometry, or we will call it calculations in chemistry. For this chapter, I am going to use 2 videos to conclude the main points you all must understand in this chapter. And again, at the end of this chapter, I am going to give you a shortcut to do calculation questions in chemistry. Remember, these steps can apply in A-level equivalent or even in uni level because the steps are always similar. Alright, so before the start of this video, if my videos are helping you all, please subscribe to my channel and share it because I'm doing this channel for free and I will consistently update the main points and answering technique for each chapter in SPM as well as IGCSE. Alright, let's start this chapter now. Okay, so for this chapter, there are 6 things that you need to take note of. The first one is the relative atomic mass. Okay, the mass of atom. The next one is the relative molecular mass, and then the number of particles, and it comes to mass of compound, volume of gas, and the last one will be volume or concentration of solution. But take note, it's for solution. However, in this video, I'm going to focus only on the first 3 and the remaining in the second video. Okay, the first one to take note, it's relative atomic mass. It is the average mass of the atom, which is what we see on our periodic table. So it is defined as the average mass of one atom and compared to 1/12 of a carbon-12 atom. What exactly is that? So it is actually 1/12 times a carbon with a mass of 12. So if you cross off the 12, you get 1. So AR, the atomic mass, is pretty much the average mass of the atom you see on periodic table divided by 1. The sole reason to write this 1/12 of carbon-12 atom, it just wants to tell you because this is a relative mass, they have no unit. We are doing a comparison with what? With 1/12 of a carbon-12 atom. So this only comes with the aim to indicate that this is a relative mass for comparison. Okay, now let's go to an example. At here, I'll have 4 examples, and as what we say, all of these have to do using periodic table. So for oxygen, you look at the bigger number, 15.9, but for our level, we will use a whole number. So for oxygen, the mass is 16. For fluorine, you look at it, it will be 19. And if you try for sulfur and silicon, sulfur is 32, and silicon at here will be 28. So it's pretty straightforward. Then the next one now is relative molecular mass. Okay, so this is the average mass of a molecule, and again, compared to 1/12 of a carbon-12 atom. Okay, a reminder from what you learned before, molecule is made out of 2 or more atoms. So the way for you to find relative molecular mass, the MR, will be the same as what you did for like the relative atomic mass. Okay, at here, again, 1/12 of a carbon-12 atom. So like what we did before, it will be 1. The way you do it will be the same as your relative atomic mass. Okay, right now, let's move on to a few examples. Okay, at here, I have 5 examples. NO2, NO3, CO2, the CF4, and H2O. Okay, take note, you can see the number 2, 3, all of them are subscript, which is at the bottom next to the letter. It means the amount of the element. Okay, so right now if you look at NO2, the N, N2O, N has a mass of 14. And then for oxygen, you have 2 oxygen, so each oxygen is 16. Your answer here is going to be 46. And the next one, NO3, it has 1 N and 3 O, answer will be 62. Next one, CO2 will be 12 plus 2 times 16, your answer will be 44. Okay, for CF4 and H2O, you can take some time to try it on your own. Okay, it will be quite straightforward. Okay, time for some revelation. So, for CF4, it will be 12 plus 4 times 19. And H2O, H is 1, so you have 1 times 2 plus 16. Alright, so you must remember this AR and MR. They are the basic that you must know in chemistry because no matter what kind of calculations you do, these are always the things that you will start from. Alright, now let's go on to mole. You have to know in chemistry, mole is also the very basic and important things in chemistry calculation. What it is actually a unit just like 1 dozen. We know that 1 dozen have 12 units. So for 1 mole, you actually have 6.02 times 10 to the power of 23. So it's just a super huge number. So if I say you have 1 mole of elephants, which means you have 6.02 times 1023 of elephants. If I say you have 1 dozen of bread, you have 12 breads. And if you have 1 mole of bread, you are going to have 6.02 times 10 to the power of 23 breads. You're going to eat that for your whole life, okay? So mole is the most important thing in chemistry. Why? Because you are going to use them to do calculation. Just like what you see below, as long as you have mole, you can use that to find the number of particles, the mass of compound, volume of gas, and again, volume or concentration of solution. However, I'm going to use 2 videos to complete the main things for these 4 items. Okay, let's move on to the first one, number of particles. Okay, you must remember here Avogadro constant, it means the big number. As for particles, it can refer to atom, molecule, or ion, depending on what the question wants. So for example, if we see here, NO itself is 1 molecule. And this molecule, if you look, it has 1 N and 1 O, so it is 2 atoms. Okay, the next one, your NO2 itself is 1 molecule and it is made out of 3 atoms, 1 N and 2 oxygens. The next one, MgNO3 too. You have to take note this is 1 molecule, but if you look at here, it comes with a bracket, which means I have 2 of NO3. In each NO3, I know that I have 1 N and 3 oxygen. So in total here, I have 1 Mg, I have 2 N and 6 oxygen. Give me a total of 9 atoms. The next one, this Al compound, it has 1 molecule, and this SO4, again you have 3. So you have 1 S and 4 O in each SO4. So in total here, you are going to have 2 aluminium. So 2 Al. And as for S, you have 3 times 1, you are going to have 3S, and 3 times 4 oxygen, you are going to have 12 oxygen. In total, 17 atoms. Okay, you must remember how to do this and take note of the term they use in exam. Is it atom, molecule, or ion? Okay, so now here comes our first equation. The number of particles equals to mole times Avogadro constant. Okay, we saw this Avogadro constant before. It is a big number. And at here, I have one question, 0.8 mole of H2O. Alright, first step, you need to know H2O itself is 1 molecule. And there are 2 H and 1 O in this molecule. So in order to find the number of particles in 0.8 mole of H2O, I will use 0.8 times the 6.02 times 1023, and this will give me 4.82 times 10 to the power of 23 of H2O molecules. Okay, at the same time, like what we have mentioned, this H2O has 2 H and 1 O. So if the question asks for the number of H atoms, you are going to use for the 4.82 times 2, because you have 2 H atoms giving you this number. Remember about this. As for oxygen here, for O, because you only have 1 O, so you are going to use 1 times 4.82 times 10 to the power of 23, and you will get your answer. So in exam, if they ask for what is the total number of atoms for 0.8 mole of H2O, you have to take note, you need to use 3 times 4.82 times 10 to the power of 23, giving you the answer at here, the 14.46 big numbers. Okay, let's move on to the next 2 examples, 0.5 mole of Na2SO4 and the Al compounds. Okay, for the first one, 0.5 mole of Na2SO4, it is 1 molecule, and we see here it has 2 Na, 1 S and 4 O. In total, give me 7 atoms. Remember the method again. And my number of molecules will be 0.5 times the number, giving me 6.01 times 10 to the power of 23 Na2SO4 molecules. And again, when a question asks you for the number of atoms, we will just use what we have learned before. Okay, since we have 7 atoms, so we use 7 times the answer above, we will get 21.07 of atoms. Okay, so now to the second example. At here, we have 1.2 mole of Al2SO4, 3. You may pause this video and give it a try before proceeding, using the same method, yeah? Okay, we know that this compound is 1 molecule. Using what we learned just now, This compound has 2Al and 3 times 1S and 3 times 4O, so giving us 17 atoms. Okay, so at here, if we look for number of molecules, it will be 1.2 times Avogadro constant, and you will get the number. As for number of atoms, you will do the same, 17 times 1.2 times the Avogadro constant. Okay, the steps are just similar. So for all you guys, the brilliant one who have managed to endure until this part, please give this video a like and leave a comment so that I know. And if it's helping you, please help to share to your friends as well. Okay, as promised, here I have 2 questions you may try. If you have any questions, you can leave a comment or WhatsApp me. I will reveal the answer on coming Wednesday. Okay, we have come to the end of this video. So apart from all the free contents on YouTube, I also have my own online lessons, which I will go into details of each chapter, and my own notes will indicate the answers that can prepare you for different types of examination questions. So I hope you all will be able to learn chemistry easily and even prepared for next level camp. Okay, see you all soon. Bye bye.